Hello, I left out something as usual in my previous lecture, so this I'll be putting up as bonus content because there's no more lectures to add it to. So we actually proved this in the previous video. If you see, x is greater than y implies negative x is less than negative y. So for x and y in real numbers, we proved that x is less than y, or did I prove? Yeah, x is greater than y would imply negative x is less than negative y. So the sign is so called being reversed when you apply. So we usually say that to learn, to make people understand more easily, we say that if x is greater than y, if you put a negative sign in x and y, the inequality reverses. Well, that's not exactly the way to remember it, but this helps. So I actually proved this. So we proved P implies Q. So if x is greater than y is P and this statement is Q, we proved P implies Q. But an interesting thing to be noted there was Q implies P is also true. Q implies P will also hold true, and hence, so this is actually called the converse of this statement. So this is also true. What do I mean by P? Q implies P? I mean that if minus x is less than minus y, this would imply x is greater than y. Well, minus x and minus y are again real numbers, because if x and y are two given real numbers, then minus x would be real number. We know this because real numbers are closed, we have seen this, and minus y will also be a real number. So this can be another real number, say a, and this can be another real number b, and if a is less than b, we have to prove that minus, so this x is negative of negative x, and it is actually negative of a, so negative a is greater than similarly negative b. So we'll have to show this. So do we understand the new question at hand now? The converse actually states that if a is less than b, then minus a has to be greater than minus b. And the proving technique again is very similar to the previous proof. So assume a is less than b, but minus a is not greater than minus b, that is minus a is less than or equal to minus b, which implies b minus a is less than 0, less than or equal to 0, which implies b minus a is positive, which implies b is greater than a, positive or equal to 0, maybe, or equal to 0. So b, which implies that b is actually greater than or equal to a, but we see that b is okay, there's a, I didn't do it correctly, I rushed through it again as usual. So b minus a is less than equal to 0 would imply b is less than equal to a. If you add a on both the sides, then this would be b is less than equal to a, which implies b minus a would be less than or equal to 0, which implies b minus a is negative, and or 0, so this is actually less than or equal to 0. So in the previous question also we did this mistake in our last video. So y minus x is greater than or equal to 0 would imply y minus x is positive or 0, right? I'm also correcting the previous video here. Okay, so b minus a is less than equal to 0, but we have assumed that if b minus a is negative, what does it mean? That a is a bigger number than b is. This implies a is greater than b, or this implies a is equal to b if they are 0. If b minus a is 0, a is equal to b, but it is the case that these both things are not true. So this is actually not p. we have assumed, so here p and q are being reversed, so I won't write not p because this is confusing, but we have proved the counter of this statement. So again we have proved the contrapositive, but we have done this for the converse of the statement. So all these things we have obtained a contradiction. All these things you should these definitions should come naturally to you. You don't need to learn these. We keep on using these in mathematics. So hence we have proved what? X is less than y. This both way implication to minus x is greater than minus y. The inequality reverses. So this is if and only if statement. So this is what I left out in the previous lecture. I hope you understand, and I hope you understand the importance of mathematical reasoning now. The reason why I don't remove these little blunders that I make, like I made a blunder here, the reason why I don't remove is because this is the way we learn mathematics, by making mistakes. So just writing maths properly step by step won't suffice. You need to learn how to think. So this is the way I think. I make mistakes in between, and you should also, I urge you to make mistakes and then correct them. So I hope you all understood. Thank you.